This demo shows a planning tool called DPO developed by DecisionBrain to optimize bike distribution in bike sharing system. DPO is used 24 hours a day, 7 days a week by the control room team that manages the London cycle hire. I now pretend to be a planner in the control room responsible for bike redistribution in London. For that, I use DPO to make the right decision at the right time, taking advantage of the insights provided by the advanced analytics engine. Once connected to DPO, I can monitor the scheme in real time using the information available in the map. Each station is displayed as a circle. The color of the circle gives an indication of the current state of the inventory as well as an indication of the evolution of that state. Vans are displayed at their current location with their current inventory. And of course, this information is updated in real time. DPO also provides a scheduling system to manage the work orders assigned to the drivers. Each line represents a driver with his or her working shift. The boxes in each line represent the work orders done or to be done by the driver over time. DPO provides all the capabilities needed to make manual scheduling decisions. I can now easily detect a potential issue in one of the stations and take the necessary action to mitigate the issue. For example, I see that this station is currently empty. Let's see what additional information I can find. I see the capacity of the station, the current number of bikes, the current number of empty docks, and the number of inactive docks. DPO also provides a forecast of the demand. The forecast is calculated using machine learning techniques, and for example, it takes into account the current weather forecast, which of course has great influence on the demand for bikes. I can see the pattern of the demand for pickups and the pattern of the demand for drop-off, and that for the next 24 hours. I can also see an overview of the inventory level of each station over time. The past inventory is displayed in blue, while the forecasted inventory is displayed in red. Based on demand uncertainty, a safety corridor is computed and displayed in orange and gray. In order to maintain the scheme in the right state, the planner should maintain the projected number of bikes displayed with red dotted line between the gray and the orange lines. The green dots represent the optimal inventory that minimize the risk to drive inventory outside the safety corridor. Remember that the inventory outside the safety corridor implies a risk of having a station that is either full or empty. If we now go back to the issue that we detected, we can observe that although the station is currently empty, there is no need to bring bikes to this station, as a given number of cyclists will soon arrive to this station to drop off their bikes. So I don't need to send any van to this station. Let's switch to another station. Let's consider this one. This station is also empty, and the forecasted inventory is far from the optimal one. Therefore, we should create a work order to send a van for replenishment. Thanks to the insights provided by DPO, I'm able to make informed decisions with a full visibility on the future inventory. I create a new work order that appears on the scheduling board. The optimal replenishment level is proposed by the system, and the corresponding duration of the task is calculated. If I want, I can rearrange easily the plan, either by modifying the field in the work order or by using the drag and drop capability. Once I'm happy with the plan, I submit the changes. DPO can also automatically compute the optimal schedule for the next few hours. A sophisticated optimization algorithm computes the optimal schedule within seconds. As soon as the solution is available, I can analyze it and evaluate it. If I validate the solution, then I submit it for execution. In the end, DPO helps planner maintaining the right inventory of bikes at the right place, at the right time, at the lowest cost.